Okay, for this question, it's part of the nonlinear equations, 3A, the most difficult level from our quiz. There are two ways to do this problem. There's the algebraic method, a little bit more tedious, and then there's the Desmos method, so I'll show you both. First, let's do the algebraic method. So to solve this, you want to maybe use the, elimination method, whereby you just add downwards. And as you do, you're hoping one of the variables is going to cancel out. In this case, we are lucky because negative y plus y will cancel out. What we're left with is 2x equals x squared minus 1 minus 3. It becomes a negative 2. So then we'll take this equation, and you see it's a quadratic equation in the making. So I'm going to rewrite it here. We have 2x equals x squared minus 2x. To solve any quadratic equation, you want to set it equal to 0. I'm sorry, not minus 2x, just minus 2. So yeah, you want to set the whole equation equal to 0. So I'm going to subtract 2x from both sides, so everything is on the same side. Those cancel. We end up having x squared minus 2x minus 2 equals 0. Now, typically what we do when we have a quadratic is to try to factor it using the X method. There are many names for this. There are many ways to write this down, but I'm going to show it to you this way. Product is A times C, sum is B. So the A value for this equation is 1. C value is negative 2. So 1 times negative 2 is negative 2. And then the sum is the B value, which again is negative 2. So we ask ourselves, is there any number that when you any two numbers that when multiplied give you a negative 2, then when you add them, you get a negative 2. And I can promise you, you're not going to find any integers that give you that. There's nothing that gives you negative 2 when you multiply, and when you add those two numbers, still get a negative 2. So because the factoring has failed, we then have to use the quadratic equation. And we can tell we want to use the quadratic equation because all these choices sort of look like a result of the quadratic equation. For those who have forgotten, the quadratic equation is x equals negative b plus or minus square root b squared minus 4ac. All of this divided by 2a. As always, it's good practice to just label your a, b, and c values. A for this equation is 1. So this coefficient right here is a 1. B is negative 2. That's this coefficient of x right here. And c is also negative 2. So now we are just going to plug and chug. So let's plug in the values. Negative b becomes negative 2, so positive 2 plus or minus square root. Be careful here because you're plugging in a negative number. You want to enclose it in parentheses because if you don't, you're not going to get the correct answer. So just plugging in a, b, and c. 2 times 1. And then we keep going. It'll be 2 plus or minus. So inside of under the radical, the radicand that is, so it's negative 2 squared gives you a 4. Negative 4 times 1 is negative 4. Negative 4 times negative 2 gives you a positive 8. That's what's under the square root. All of this divided by 2. Now I'm running out of space, so I'm going to move this over here. Let's keep working. So we end up having 2 plus or minus square root of 12. All of this still divided by 2. Now the square root of 12 can be simplified because you can reduce radicals. So square root of 12 breaks down to 4 times 3, and then you know that's still under the root, so end up having 2 root 3 because the square root of 4 is 2. 2 goes out. So now I'm going to write that here as 2 plus or minus 2 root 3 over 2. If you look carefully, you'll find that this 2 goes here and also here, so we can simplify this entire answer. We end up having 1 plus or minus root 3. So that becomes our x value. Now when you look at the answer choices, there's really only one that has 1 plus root 3. There are two answers here, 1 plus root 3 and 1 minus root 3. We really just need to do one. It's a time-saving strategy, so that will be the answer A. There's no point of even plugging in the second one to figure this out. So that's method 1. You can see this is tedious, but I thought it useful to go over this because it reminds you several things. One, how do you how do you solve a quadratic equation using the quadratic formula, like that. Second, the elimination method of solving a system of equations. Third, even though we didn't use it fully, we saw there's a way to factor quadratic equations. So it's not just about getting you to the answer, but it's also about reviewing other things that you're going to need. With that said, let's look at the other method, which is the Desmos method. Okay, so now we're going to use Desmos to answer the same question. Notice how much quicker we can answer this. The first thing you must do is rewrite the equations to make y the subject. So for the first one, which is x minus y equals 1, we need to make y the subject of this equation. So let's start off by subtracting x from both sides. We're going to end up having negative y equals negative 1 plus, negative x plus 1. But we want y to be a positive, right? So you have to divide everything by negative 1. So basically change all the signs, and we end up having y equals x minus 1. So that's the first equation that we're going to enter here in Desmos. Now we're going to repeat that for the second equation. Let me draw a line here. We'll do it again. We got to get y by itself. So x plus y. We're rewriting this equation. X plus y equals x squared minus 3. So to get y by itself, we need to subtract x from both sides. So those are canceling. We're going to end up having y equals x squared minus x minus 3. So once you have both equations, you're going to plug each one into Desmos like this. So let's do the blue one first, the quadratic equation. Y equals x squared minus x minus 3. And let's enter the linear equation in, I think that's purple. Y equals x minus 1. So now you notice where the two equations are intersecting. This is the first intersection, and this is the second intersection. So remember, the solution of the system is where the two graphs are intersecting. So right here and right there. So here's the problem. You look at the answer choices, and these choices are presented to us in exact form. That means they're not in decimal form. But not to fret, because we know the answer is A already. So, if I take 1 plus root 3 and I enter it here, 1 plus square root, and you can literally type in sqrt 3. It gives you the answer, 2.73. So we're looking for the x value. 1 plus root 3 is equivalent to 2.73. So if I go over here, I'm noticing that x value is 2.73 right there. So then we know that A is the answer, and that's it. So you see, Desmos is a lot quicker.